Limits by Factoring with Synthetic Substitution by Erica and Olivia. Here's the equation we'll be working with. The limit as x approaches 6 of x squared minus 9x plus 18 over x minus 6. Now you may be thinking,
the limit does not exist. The limit does not exist!
Because when you plug 6 into the equation, you have the limit as x approaches 6 of 6 squared minus 9 times 6 plus 18 over 6 minus 6. And when you solve that out, you have the limit as x approaches 6 of 0 over 0, which is technically just 0, but because it's in the indeterminate form, it means that the limit does not exist. So, you have to do synthetic substitution.
So in order to perform synthetic substitution, you need to have a number in the box at the top because that is what you are trying to divide by. Like how in polynomial long division, you would be dividing by the entirety of the x minus 6 because you would be dividing everything, like the x squared minus 9x plus 18, but you only have one part of the factor using synthetic substitution, which is the integers. So you take the coefficient or integer from each part of the function that is being divided, x squared minus 9x plus 18, and write them at the top of the formula. And you write a 1 for x because there's no written coefficient. So you then move the 1 down to the bottom under the equals bar and multiply that by the number in the box, which is in this case 6. So that equals 6, of course. So then you put that up under the negative 9. So negative 9 plus 6 is negative 3, and then you would multiply the negative 3 by 6 and are left with negative 18, which cancels the positive 18. And the 1 and negative 3 left represent x minus 3, which is your new factor for your equation, where the other factor is x minus 6 because that is what you factored out of the original equation.
Therefore, the equation of the limit simplifies down to the limit as x approaches 6 of x minus 6 times x minus 3 over x minus 6, where the x minus 6's cancel out because of the common factor. So you are left with the equation of the limit being the limit as x approaches 6 being x minus 3. So when you plug 6 back into the equation to find the limit, because it's limit as x approaches 6, it equals 6 minus 3, which equals 3. So the limit as x approaches 6 equals 3.
So when you're solving for a limit, and you think,
the limit does not exist. The limit does not exist!
try synthetic substitution. To justify using synthetic substitution for this equation, we graph the equation, which shows a hole at 6, 3, which makes sense because at the point 6, 3, the equation is in its indeterminate form. But when you use synthetic substitution like we did, you simplify the equation and get rid of the common factors, which leaves you with an equation that will give you a value at when x equals 6.
We chose this topic because we both originally had trouble trying to solve these problems with polynomial long division.
We found that synthetic substitution was much easier and more efficient because there are a lot less steps involved, which makes it faster than long division and more concise.
And because of this, it makes it much easier to justify your work to other people, leaving less confusion when explaining.
Yeah, because your work is a lot more easy to follow.